I'm Matt Asher, and you've found The Filter on YKYZ. My guest today is Andrew Gelman. Andrew is a professor of statistics and political science and director of the Applied Statistics Center at Columbia University. He's the author of a number of books on topics such as Bayesian Data Analysis, How Stats Should Be Taught, and Voting Patterns in Politics. Andrew, welcome to The Filter.
I'm glad to be here.
Great to have you here. So the main focus of our conversation today is the role of statistics in politically charged environments. But I want to begin with a small point of overlap between us, which relates to a journal article that should also be a good jumping off point for our conversation. Andrew, you published an article titled The Statistical Crisis in Science in December of 2014, but I knew that article was coming out about 3 months early when someone from American Scientist magazine contacted me. They asked for my permission to use an illustration of Ronald Fisher, one of the pioneers in the field of statistics. I had that illustration created for a comic book I made shortly after I was done studying statistics, and I posted it along with some other sample images to statisticsblog.com, where it was seen by the art director for that magazine. Now, I find that overlap somewhat interesting, but I can't imagine it qualifies me for a Gelman number, does it?
That's your call.
Well, at any rate, after your article came out, I read it, of course, and I've thought about it over the years, along with some follow-up articles you wrote. The basic idea in the article is that in the course of analyzing the results of an experiment, researchers have lots of choices about which models to run and how they run them. So even if they aren't trying to game the system, this large number of forking paths they could go down increases the possibility they might find something that isn't already there. One of the other things that these forking paths allow us to do is pursue either consciously or unconsciously our biases, especially in the case of open-ended inquiries where the researchers pick which subjects to investigate and how they'll examine the data. It seems inevitable that to some extent findings will be predetermined by the researchers' biases. I'd go even farther and say that right now, when it comes to anything with political, and in particular anything with partisan implications, our priors now completely determine our posteriors. Andrew, could you start us off by explaining those two terms and let me know if you agree with that assessment?
Oh, I disagree with that assessment. Your prior represents your model of the world before you've seen the data, and your posterior represents your revised model of the world after seeing the data. But it depends on your goals. If you're trying to win an election, then you want to learn about reality. It doesn't help to fool yourself, right? So it kind of depends on what your goal is. Like, for example, a few years ago, and even more recently, but a few years ago, there were various pollsters trying to talk Mike Bloomberg into running for president. Well, maybe they agreed with Mike Bloomberg. Maybe they thought he'd be a good president. Maybe they just thought that he would pay them a lot of money if they could talk him into running for president. Whatever the reason, their immediate goal was not to get him elected president. Their immediate goal was to get hired. And so in that case, to get hired, you have to convince him that he has a chance of winning. So sure, that's a case where they have a high motivation to get a result in a certain direction. And there, I would think that their posterior would be very similar to their prior, that they would just construct a model and construct a system so that they could conclude what they wanted to learn. Another example would be someone whose goal is to publish a paper in a journal and get headlines. They have a motivation for finding a dramatic result. But in other situations, that's not the case. In a lot of situations, you are motivated to find the truth. I spend a lot of time on research on computational methods, trying to come up with more efficient, computationally efficient and accurate ways to fit statistical models. it wouldn't make sense for me to try to talk myself into thinking my methods are better than they are, because ultimately I'm trying to solve problems. It just depends on what your goal is. So if your goal is to forecast, to help figure out where your company should make investments, then your motivation is to get to the truth. Fooling yourself will just hurt you. On the other hand, if your goal is to sell a forecasting routine, then you might have a motivation to find dramatic results. You get that kind of principal agent problem.
I would think that in addition to those cases where you want to fool yourself, there's also the use of statistical prediction models and models in general as a way to try to push conversations in a particular way, no?
Yeah, so sure. So if I support a certain political position and I'm a pollster, let's suppose my goal is not to win the election, but my goal is to influence the political conversation. What if I'm trying to convince a bunch of Congress members to vote a certain way? Then sure, I have motivation to slant the results, because if I can convince them that my position is popular, they might change, how they vote. And then maybe the position will become more popular. Who knows? So it depends a lot on what your motivations are. Motivations are like gravity, right? Like you don't need to push in that direction. If you don't actively push against it, you'll kind of get sucked into where you're trying to go.
I think that's a good analogy, and I think it ties into the idea of priors, and especially strong priors, and the effect that they have on our ability to change our minds later when new information comes to light. In your article about the statistical crisis, you mentioned the idea that these forking paths might be behind the experimental results, like the ones we sometimes see that seem to validate ESP. In that we discard the idea of it being real, and then results come in and we still discard it because we've decided that something must have been screwy with that experiment and not that it was real, right?
I would say a little differently. There was a famous paper published by a psychology professor in 2011 in a top psychology journal that claimed that students at Cornell University had ESP. But you look at the paper and they do several experiments. Each experiment they analyze differently. There are many different paths in their experiments. So it's just not like, oh, they did this study, but we don't believe ESP, so we have this vague feeling they did something wrong. You can just look at their paper and see that they did not do good science there. It doesn't matter if I believe in ESP or not. It's just bad science. The only notable thing about it was that it was published in a top journal. If it hadn't been published in a top journal, no one would have taken it seriously. I've thought about a lot about this. Why would the journal publish such a bad paper? Part of it is FOMO, right? Like, oh, well, what if? This is super important. I mean, there are papers that are just as bad about things that don't violate laws of physics, but we have the same feeling about. Like there was the paper that claimed that women were 20% more likely to vote for Barack Obama during a certain time of the month. Now, that kind of violates what we understand about politics, but it doesn't violate any physical laws. But if you actually look at the paper, you see that the authors made a bunch of arbitrary decisions which allowed them to find a pattern from pure noise. So sure, like I guess if you have some prior understanding, that can give you skepticism about it. But these papers do not provide serious evidence of anything.
I want to keep pushing a bit on that idea, the strong priors, and I want to loop in my favorite chapter in a book on stats or probability. E.T. James has a chapter called Queer Uses for Probability Theory, in which he explores the trickiness of integrating new data into our belief system when we start from a place of near certainty. And he discusses ESP at length in that chapter. And he comes to the conclusion, supported by the math, that even if the claimed result breaks in favor of the hypothesis, we might actually become less convinced after the data comes in because we conclude that some other factor caused the results. And thus, instead of something in support of what the data seems to show, we latch on to this alternative hypothesis, decide it's more probable, and then go down that path. And I actually want to read a quote from his that maybe ties us into the present moment. So this is from about 20 years ago. Janes writes that unlike in the world of political opinion, quote, scientists can reach agreement quickly because we trust our experimental colleagues to have high standards of intellectual honesty and sharp perception to detect possible sources of error. And this belief is justified because, after all, hundreds of new experiments are reported each month, but only about once in a decade is an experiment reported that turns out later to have been wrong.
Yeah, that's hilarious that he said. Did he really say that? You have to send me that quote. That's
Sure thing. Yeah, that's
I'll
right
have to
from the
blog
book.
that. That's whether things were really like that in the 1950s or 60s or 70s when he wrote that, that's certainly not the case now. There was a journal, Psychological Science, which, like, during its heyday in the mid 2010s, I think that there was a point where more than half the papers they were publishing were junk science. I mean, literally more than half. I haven't done a formal study, but I remember looking at their papers, and it was just like so much was bad. That's really hilarious that Jane said that. I guess physics is a different world, and physicists working in the world of physics, I think, are pretty serious. And when physicists go outside of physics, like, they're kind of leaving science usually. Sometimes physicists write about political science and they say some silly things, but it's kind of not even science anymore as far as they're concerned. But I guess so. I guess it depends on the field that you're talking about. So the thing with priors is that they're kind of needed to learn about the world. I've done some work in drug development, and there you have a lot of prior information about what a drug might do. To understand how the drug is working and model what's happening inside the body, you need to use that prior information because a lot of the inferences interact. You can't always measure the concentration of the drug in all parts of the body. Sometimes you can only take external measurements. But in order to determine things like dosing, you need to make inferences. So that kind of modeling is absolutely needed. And similarly in politics, there's a million things that they don't even ask people about because they feel that they already know the answer. The last time you did a survey, probably no one asked you if you believed in nationalizing the means of production, because that's just not considered a popular position based on our previous understanding of politics in the United States.
Yeah, so you certainly, I think it's accurate to say you can't really get anywhere without a prior, even an implicit prior. But then things do get kind of wiggly as you get closer and closer to certainty with your prior. And I think that there's certainly a concern, at least on my part, that as people's priors, especially within a political context, get closer and closer to certainty about a particular view or a model, a prior model of the world, then it makes the posterior, I guess that was my earlier point that you discarded, that is to some extent predestined when you have such a strong prior.
I think your inferences are conditional on your model of the world. So there are different ways of setting up models. When we did our election forecasting model with The Economist, the prior is based on economic and political conditions based on a model we fit to historical data. So there is some assumption that there's some continuity between past and current elections. You kind of have to make some assumptions along those lines. But then that's part of your model. And it's important to state it explicitly, I think.
As I mentioned previously, I studied stats, but before that, I discussed journalism. And for years now, I've watched as journalism seems to become subsumed by political advocacy on one side and the other. And of course, lots of people have seen this too, which explains, I think, why journalists are held in such low regard right now. But what I'm seeing now, though, and what I'm concerned about, is that even those in the field of data science, either by their silence or direct involvement with faulty data and flawed processes, are headed in the direction of journalists. And I'm wondering if you see the same thing and you have a concern about that as well.
Can you give an example? I'm not quite sure what you're saying.
Sure. So I think that the best way to get into an example would be to talk directly about what's gone on with things like the data related to COVID. For example, it's been reported that the number of deaths include people who have died in car accidents, people who have died of gunshot wounds. This is not speculation. These are the things that we've found. There's no consistent way in which the data is being reported from one state to another. Things are not being reported with margin of error bars. I would expect, in the light of those flaws in the data, but a number of others, I could keep going with examples if you want, that those in the data science profession would be more aggressive in speaking out and saying that it's not a fact that 130,000 people have died. That's an estimate, and it's based on the following things, and here are the problems with that estimate. Early on, that estimate may have been too low. Now, based on some other things, it might be too high. But I'm not seeing a robust pushback against that data as presented. Does that make sense?
Yeah, no, that makes sense. That's an interesting point. I haven't thought too much about it. I guess one reason, I think it is recognized that there's problems with the data. And I think there's some general sense that we would expect that there'd be trusted government agencies that would be taking care of this. And like the census isn't perfect, but we use the census and we have a sense. I mean, I know people who work there, and they're professionals. It's like what they do for a living, and I feel like the census numbers are as good as they're going to be, and they do their best. And I agree with numbers like this. Like you'd want, whether it's the CDC or whatever, I think we would want to trust numbers like that. And I think these numbers have so many problems. Like, why am I not like writing a blog entry, saying, hey, everyone's reporting this number of deaths, but we don't know. Partly it's a fundamental problem of measurement. Like it's not like the government can wave a wand. Like in other countries, they have difficulty too. It's not always clear how to classify a death. I mean, there is a well-known problem with classifying deaths, that you can die of more than one thing. And sometimes they don't know what people die of. So this, in that sense, this is not new. Sometimes people have talked about using total deaths compared to total deaths in previous years, breaking it up by age group. Of course, that has issues too. Like when we criticize a scientific study, well, we're no longer in the age of Ed James. And so if some bozo from Harvard or whatever does a study, I can well believe that they just screwed up. They had bad data. They don't know what they're doing. It happens all the time. I think we're not so used to the idea that the government agencies can be having similar problems. So maybe it is taking us a while to adjust for that.
I think that the things that you mentioned are really important parts of context, basically, that should be go along with the data as it's presented. Perhaps the issue here is that while I think that the kind of statistical profession has done a good job of getting the media to report on margins of errors in certain contexts, in terms of, say, polling data or whatnot, the media generally does tend to provide the plus minus for that. But they are not doing that in this context. And I don't know whether that's just because it's so new or because there really is a failure on the part of people in data science to shout at the TV, but actually call up the reporters and shout at them and say, hey, you can't just throw these numbers out here. You have to provide that kind of context. You have to provide it in the context of the problems with this or the error bars, and not just give a single point and treat it as if this is the fact.
Oh, well, this is just the way things are. I mean, look at this. They report the stock market all the time as if that, I mean, as if that's so meaningful, right? Like, who cares? Like, I mean, at some level you care, but this precise number, it's not a matter of an error bar, but the stock market, it's a bunch of stocks. Like, there's a lot of things that could be reported, right? So, like, I think that in the news, they're used to the idea of reporting a single number. So, they report the number of people who have the disease, who have been tested positive, even though it depends on who gets tested. Top medical journals publish papers based on these data. I was asked by a reporter a few months ago to comment on a study that had been done in New York State, and I gave some comments, and then I sent the reporter an email and said, please don't quote me, period, on this, because it had been a study that was done and there was no report. Like, just not only did they not share the data or their code, there was not even a report. They just supplied the numbers. Like, single numbers get reported. I don't think having an error bar would really resolve the issue. There's just a lot of uncertainty, and that's not what people want to hear.
I think what worries me most, and you mentioned medical journal, is that in this environment of uncertainty and the inevitable kind of fog of war that you have when a new thing comes along and is so impactful, that you also, that this uncertainty can become a place where you can drive through the door things that shouldn't go through the door. So in terms of drugs and medical journals, there was the article that had to be retracted about the drug that Trump had mentioned several times because it was completely fabricated. And I'm left with the impression that that's the kind of thing that wouldn't have been accepted by the paper if it had broken the other way and also had been fake. My prior, anyway, based on the experience and based on what I've seen here, is that what the uncertainty does is allow for people who are in a position where they should be doing unbiased science to grab onto a result that is favorable to the particular position that they have and give it extra wind, and at the same time perhaps spike other things that might be perfectly valid studies but that cut the other way.
Yeah, I don't know. I think they're happy to publish good news or bad news. Maybe want to publish things saying we don't know, but saying this drug is saving lives, they're happy to publish that. This drug is killing people, they like publishing that too. I guess from the journalist point of view, I mean, they're just reporting what's out there.
I think what would give me more faith in the story that you're describing there, not to be pejorative with the word story, just in terms of your model or your way of coming at it, what would make me more inclined to believe that is if I didn't see situations where people report the wrong thing and they get into a lot of trouble for reporting it, even if that wrong thing is just mainstream science. So I imagine you're familiar with the story of David Shore from Sivis Analytics.
Oh, I know him. I'm friendly with him. He's a great guy.
Yeah, tell us a little bit about what happened there and how you interpret that, what
Oh,
happened.
I actually have no idea what happened there. My colleagues and I have like helped him a bit with his statistical modeling that they're doing at Sivis, but then I just heard about this, so I don't know anything about that. I don't have any. I mean, it's not like I know stuff and I'm not telling you or whatever. I just really don't know anything more about this thing you do.
Sure. So for the listeners, he was fired apparently for a tweet that was about some research that had been done related to whether or not violent protests were a good or a bad idea politically. And apparently there was nothing controversial about the study that was done. It was just a straightforward study of that. And all he was doing was reporting on that study, just tweeting about that study in the current context, and then he was fired. Is that correct from your understanding?
I don't know. I actually just don't know. I mean, stuff has been reported, but like it all seems kind of second or third hand.
That's fine. I'm curious to get your take and where you see it. From where I sit, and based on other people that I've interviewed, including someone who was part of the Harper's open letter about cancel culture and the pressures that it puts on journalists doing their job, I see a lot of push to not say certain things or to say certain things. But maybe from your position, you don't see that, or you're immune to it, or you don't think it's having any impact on the field.
I don't know. I mean, it's different. Like, academic political science, and I don't see that happening. I mean, but there are a lot of issues when you're talking about partisan organizations on the left or the right. And you certainly hear stories about people who are let go by organizations because they're not politically simpatico. It's not really something that's come up with me, but that doesn't mean it can't be happening.
Got it. Then maybe you'll just move on unless you had any other thoughts on the political pressures being brought to bear on people doing data science.
Not the right person to ask, just because I don't really see there being political pressures. I think it's got to be much more of an issue with either with organizations that are explicitly ideological. If you're in some position where you're in the public eye, maybe that's a little bit different. Like I don't know that it really arises. I'm sure there are lots of cases of data scientists at companies who come up with a recommendation that the boss doesn't want to hear, and then the boss has to decide what to do with it. Again, there's a principal agent problem, right? If you're a data scientist, are you working for the company or are you working for your boss? What if you say, like, you do an analysis and the best recommendation is that your own division gets axed? I can only assume that kind of thing happens a lot. I think it's most likely happening in the other direction, that there are people with very strong political views who will try to push those views. And then there's the question in different organizations where that's appropriate and where it's not. There's a place for straight news and there's a place for opinions, right? And all organizations have that. There's going to be a balance. But in my own work, it hasn't really come up that much. Even my work in political science is kind of technical, tends not to be heavily value laden. And even if it is value laden, I try to put things in a larger context. But I'm lucky to be at an organization that lets me do what I want. Very lucky.
Yeah, I'm glad that you haven't felt then the pressures to produce work that falls on one particular direction.
No, I've never felt any pressure. The only pressure I've ever felt is that, like, if I write something negative about someone who has media connections, then they can attack me in the media, and then that dissuades me from doing that. But, like, yeah, I guess that's fair enough. Like, if I don't want to be attacked in the media, then, like, yeah, there are things that you might want to say or not say because of that. Yeah, that's not like pressure to have a particular political slant or anything like that. And almost all the people who I've criticized are very play by the rules, right? So, I've criticized David Brooks, the New York Times columnist. I've had cordial emails with him, but I've been pretty harsh because he's written things that are false. He makes mistakes and doesn't correct them. And so I'm annoyed, and he's kind of annoyed that I'm annoyed, but he doesn't correct anything. He's a professional, and he knows that he's going to get criticized. He doesn't respond to criticism the way I would. If I would criticize directly, I would respond directly, and he kind of avoids it. But he's not behaving in an unprofessional way other than that. So I think generally in academia and the media and so forth, most of the time, people who I have criticized, like, just accept that as part of the cost of doing business. If you publish stuff, then you have to accept that people might disagree with it. That's how it should be.
Great. So before we wrap up our conversation, I want to talk about model uncertainty in general. One of the broad trends in modeling is the growing understanding that not everything is normally distributed. Now, of course, we've known that for a long time, but we've tended to discount the possibility that data points which appear to be extreme outliers might instead be a sign that the thing we're trying to model is nowhere near as normal as we thought. In my view, a lot of the credit goes to Nassim Taleb for advancing the discussion on how these so-called outliers can have a major impact on our world and how we often assume normality at our own peril. When I was doing my own work on statistical distributions, I became obsessed with the idea of modeling extreme states of uncertainty. And during that time, I came up with what I call the unreliable friend distribution. So, for example, suppose you have an unreliable friend and you're waiting for them to show up. It may be that most of the time they arrive very close to the time that you've agreed to meet, but the later they are, the later you expect them to be. So if they haven't shown up after 10 minutes, then you expect it'll take another 10 minutes on average. If they're late by an hour, you now expect to wait another hour before they arrive. With this particular distribution I created, your expected wait time becomes equal to your wait time thus far. Now, the formula for this is pretty simple, but the related mindset is actually a pretty big shift from our usual assumptions about the world. Intuitively, for any given project, we tend to believe that uncertainty decreases or diminishes over time, but this unreliable friend distribution encapsulates the opposite idea that uncertainty can grow over time. And in my view, this is the perfect distribution for modeling many of the things we find hard to model, like how over budget and over time a large public works project might go, or how long will it take to figure out if a mathematical theorem is true. And if there's anything that I'd like to add to the conversation that Taleb popularized, it's this idea that we don't always get more clarity over time. In fact, often the margins of error can get larger, not smaller. I'm wondering, Andrew, if you could reflect on this idea of what might be called revealed uncertainty and its role in our understanding of the world.
I will say two things. So first, yes, you can find out retroactively that we knew less than we thought we knew. That reveals a failure in the original model, right? So the original model should have accounted for that. And part of it is we sometimes do shorthand. So we have a model conditional on certain things not happening, and we recognize that, but then we kind of forget about it. With your unreliable friend, maybe you should have realized ahead of time that this friend might have been several hours late. Like your original model was perhaps too optimistic. So if your original model had been more realistic, then you'd be less surprised. So that's one thing. The other is I would move away from thinking about a distribution or something being non-normally distributed or whatever, and think more about the time series. So this is something from the 1920s and onwards. They called statistical process control or quality control. And the idea is that there's some certain amount of variation over time. The goal in process control is to stabilize the process and reduce that level of variation. Or things can get out of control and no longer be predictable. So, of course, we see that with climate change, right? There are various floods that are supposed to be very rare, and yet they keep happening. And things like that. The issue is not so much that there's a long-tail distribution. The issue is that there's not the stability that people thought was happening.
I think what you said doesn't get at, for me anyway, is the notion that over time what we learn is, I guess the way you put it was that our model was wrong. I don't think that it's necessarily that the model is wrong. I think it's just that what we're learning is that something may be a harder process than we thought. So the way to model it, in my view, would be with a distribution that allows for uncertainty to grow over time so that you could properly model, for example, like I say, how long is it going to take to resolve a mathematical theorem? If you just wrote one up on the board, the chances are that it's either going to be something pretty trivial, which you can solve quickly, but if it's something hard, then it might be very hard. And if thousands of mathematicians have worked on it for, hundreds of years and still not resolved, then it may be something that's going to take another 200 or 300 years to resolve.
Yeah, I'm not sure. I'm not sure what to think about that.
Fair enough. Andrew, thanks for coming on The Filter.
Sure, happy to do so. And have a good day.
Thanks for listening to The Filter with Matt Asher. You can find show notes at thefilter.org or follow user Matt Asher on the socials. On the socials. On the socials.